This is the overtone series of a vibrating string. They are also called partial tones. The frequency ratios of the individual tones result in the intervals of our music. These intervals are part of the overtone series, as they occur on a vibrating string on all string instruments or on a half-open column of air on all wind instruments. Therefore, they are called just intonation. In the chromatic scale as we use it today, the tones are tuned slightly higher or lower. We are talking about equal temperament here. However, our ear can hear the intervals as whole numbers due to our hearing tolerance. The scale is also given in tone levels, making it unnecessary to specify the pitch name. So I is always the first pitch, regardless of which note is in the fundamental. These tones can therefore be moved across the scale. Within the scale there are some tones that have a special relationship to one another. They are the notes C, F, G, C. If you want to specify the tone sequence independently of the fundamental tone, then it is the tone levels I, 4, V, 8, and instead of 8 you can also specify the level I, which is 1 octave lower. Usually, Drek sounds are placed over these for basic tones and are referred to as the basic or full cadence, tonic, dominant, subdominant, tonic. These tones have a frequency ratio of 6 to 8 to 9 to 12. These are the tones 1, 4, 5, 1 or 8. The triads that are common today were not known until the Renaissance. The music was essentially monophonic, as we know it from Gregorian chants. The Musica Enchiriadis from the 9th century was the first writing of polyphony. However, the accompanying voices are limited to the 5th, 4th, and octave, the intervals of the basic cadence. It was only with the Renaissance in the 15th century that polyphony of triads and polyphons developed. The reason was the discovery of natural third, which replaced the third of the Pythagorean scale. The 4th interval was divided into a minor and major third. The empty fifths could now be filled with thirds. The major third, followed by the minor third, includes a fifth and forms the major triad. The minor third followed by the major third forms the minor triad. The accompanying voices now became increasingly complex and included all intervals from the octave to the whole tones. With the parallel keys in major and minor, here C major and A minor, the way was clear for the development of the circle of fifths and the tempered scale. Music took off in a way that we probably won't see again in 1,000 years. That's what's left of the old music is the basic cadence. This now also appears as a bass voice. If you move them down by a minor third, the same sequence of note sounds, only the fundamental tones are at the base of the minor triads, and they are now called tonic parallel, dominant parallel, subdominant parallel. They are combined in many ways and is also referred to that extended cadence, but their origin is the basic cadence and thus the frequency proportion 6 to 8 to 9 to 12. I would like to summarize with a quote from Ziegenrucker's book on general music theory. He writes, "The term cadence, basic cadence, was originally understood to mean a final formation and conformation of the key. That means cadere from the Latin verb to fall or to end. However, from around 1600 to 1900 and partly up to the present, the cadence formed the determining harmonic basis of our music making. The model of the basic cadence is usually reproduced in a 4-voice setting. We want to show once again explicitly that this sequence of tones is identical with the designated number structure. I use the frequencies starting at middle C on the piano. We hear an octave interval when the two tone frequencies are in a ratio of 2 to 1, a fifth when they are in a ratio of 3 to 2, a fourth when they are in a ratio of 4 to 3. The fundamental tone 1 to 1 is also part of the calculation. We bring the fractions to the same denominator. If and only if the proportions are of interest, we can omit the denominators. The Roman philosopher Boethius called this sequence of numbers harmonia perfecta maxima, because it contains not only the intervals of the music of the time, but also the harmonic and arithmetic mean. Before him, the philosopher Nicomachus of Gerasa called this sequence of numbers the primary Tetraktys. It contains all the intervals of the Pythagorean Tetraktys. For the Pythagoreans in the 6th century BC, Tetraktys or fourfoldness was the symbol of their alliance. As we now see, this sequence of tones as a frequency or pitch ratio has a special history that goes back 2,500 years. It begins in ancient Europe with the legendary philosopher Pythagoras, who was born on the island of Samos. Pythagoras never left a single line in writing. His teachings included not only mathematics, but also ethics, philosophy, and music. The Greek philosophers after him were always also music theorists. Even during the Middle Ages and into the Renaissance, philosophers were well educated and all well versed in music theory. The Pythagoreans taught in their philosophy the unity and harmony of the world. The world was therefore not just material, but the material that formed the world was harmonically structured. Pythagoras is considered on the one hand to be a religious and ethical reformer of his time, and on the other hand to be a rigorous scientist, especially a mathematician. During the Middle Ages, he was considered the most important music theorist. He was the first person we know of who placed the importance of numbers at the center of a world view. According to ancient tradition, Pythagoras was the first to use the word philosophy in the sense we are familiar with. In Croton, he founded the secret society of the Pythagoreans, which was named after him. The strict rules of this secret society were based on the assumption that the goal of man was to imitate the divine world order, and that this order was of a mathematical nature. It was only with the discovery of quantum physics in the early 20th century that the truth about the Pythagorean assumption that the world is mathematically structured was discovered. But not only that. The tetractical fourfold structure of atoms was also discovered. When Wolfgang Pauli discovered the fourth quantum number and thus the exclusion principle, he too was convinced that the atom had a fourfold structure and that Pythagoras had been right about the fourfold nature of the world. The numbers of the maximum occupancy of the atomic shells, which are a name for the principal quantum numbers, are twice the squares of the simple integers 1, 2, 3, 4. They are therefore tetractically or 4-unit. There are for principal quantum numbers. There are also for basic forms of electron orbitals. There are only 4 of the elementary particles are stable, they cannot spontaneously decay into lighter particles. These particles are the photon, quantum of light, the neutrino, the electron, which makes up the atomic shell, the proton, one of the building blocks of the atomic nucleus. There are for properties of elementary particles that can be measured directly: charge, mass, spin, decay time. There are for interactions are possible between elementary particles: the strong interaction, the electromagnetic interaction, the weak interaction, gravity. There are for conservation quantities of classical physics are known: energy, momentum, electric charge, angular momentum. After the early years of quantum physics before the Second World War, people began to use particle accelerators to break up atomic nuclei after the Second World War. The resulting particles were so diverse that nuclear physicists spoke of a particle zoo. The American physicist Murray Gell-Mann and the Israeli Yuval Ne'eman succeeded in integrating the particle zoo of elementary particles that had emerged in the 1950s into uniform structures. This was linked to the theory that the nuclear particles neutron and proton should consist of even smaller particles, the so-called quarks. Many particles could be combined from 3 quarks, the d, u, and s quarks. Later, 3 more quarks were discovered, and with then all of the elementary particles found could be combined. The symmetries that emerged were again very simple. They were the hexagon and the so-called baryon decuplet and other structures that were derived from cube cross-sections and Archimedean solids. With the baryon decuplet, the Pythagorean Tetraktys was rediscovered in its old number-figured form, as handed down by the Pythagoreans. The hexagon and other simple symmetries also took on a completely new meaning. Many elementary particles such as mesons, medium-weight particles, and baryons, heavy particles, also fit into the order of the meson or baryon octet. If one generates a whole positive number from strangeness and isospin in the order of the baryon octet, the old number structure of the Rosicrucians and the Kabbalistic tree becomes visible. There have been some clear statements by great quantum physicists that show that we have rediscovered an old, forgotten philosophy in the 20th century. In modern philosophy, people talk about the return of natural philosophy. With the discovery of quantum physics, it was now evident the world is based on whole numbers, as the Pythagoreans believed. In his book Pythagoras, Ernst Bindel quotes a passage from Aristotle's Metaphysics about the Pythagoreans. He says, "Since they now also became aware that the relationships and laws of musical harmony can be represented in numbers, and since all other phenomena also showed a natural relationship to numbers, but numbers are the first thing in nature, they came to the idea that the elements of numbers are the elements of all being and that the entire universe is a harmony and a number." At the Nürnberger Harmonic Symposium 2012, I was able to show how the solutions of the Schrödinger equations for the hydrogen atom exhibit potentials of equal charge, the boundaries of which in turn correspond to numerical proportions of music. Hear the p orbital. The core structure of the Kabbalistic tree of life of the 10 Sephiro has the numerical order of the meson and baryon octet. The numerical sequence only begins at 3 instead of 1. It has now taken 2,500 years for philosophy and science to stop laughing at the statement that the world is number, because the Pythagoreans were literally right. This is expressed in a quote from the cosmologist John D. Barrow when he says, "The quantization of energy levels also brings about uniformity of nature." Werner Heisenberg writes in his autobiography, The Part and the Whole. Since Planck's famous work in 1900, such requirements have been called quantum conditions. And these conditions brought that strange element of number mysticism into atomic physics that had already been mentioned. Certain quantities to be calculated from the orbit should be integer multiples of a basic unit, namely Planck's constant. Such rules were reminiscent of the observations of the ancient Pythagoreans, according to which two vibrating strings sound harmoniously together when their lengths are in an integer ratio at the same tension. The Munich quantum physicist Arnold Sommerfeld, discoverer of the fine structure constant, says, "What we hear today from the language of spectra is a real music of the spheres of the atom, a harmony of whole number relationships, an order and harmony that increases despite all the diversity. All whole number laws of spectral lines and atomism ultimately flow from quantum theory. It is the mysterious organon on which nature plays the spectral music and according to whose rhythm it regulates the structure of atoms and nuclei." According to tradition, the discovery of the connection between pitch and string length, attributed to Pythagoras, was made on the monochord. According to the report of Nicomachus of Gerara, a Pythagorean of the 1st century AD, this already had for strings. The Pythagorean scale only required two intervals, the octave interval with a frequency or pitch ratio of 2:1 and the fifth interval with a pitch ratio of 3:2. From this, a scale of whole and half tones could be formed by fifth layering. This scale was very similar to the equal temperament that we use today. The musicologist Hermann Frogner writes in Lebendige Tonwelt, the change to the Terpander scale carried out by Pythagoras was an ingenious move of penetrating wisdom, which reveals its author to be a truly enlightened mind at the height of his overview of the context of musical development. Terpander, or in Greek Terpandros, was a musician of the 7th century BC. The Greek scales in general and also those of Terpander consisted of two tetrachords joined together. The Terpander scale avoided the tritone BF by using the note B. The scales were heard from top to bottom, E, D, C, B, A, G, F, E. Pythagoras replaced the note B minor with B major and joined the two tetrachords together, separated by a whole tone. The fifths fit together symmetrically from above and below. Today we would call them dominant and subdominant. This scale has the fifth-fourth structure we are talking about here. Today we call it the basic cadence. The pitches are in the ratio 6:8 to 9:12. Frogner also sees this symmetry as a reflection of the inner person. The lower fourth represents material existence, the upper fourth represents spiritual existence. Both are intertwined by overlapping fifths. The mystic Robert Flood expresses this idea clearly in one of his illustrations. Today we can see a modern version of these ancient alchemical concepts in the Indian system of chakras. What we hear is the so-called basic or full cadence. These are the tone levels: 1, 4, 5 and 1 again. Instead, you can also use the 8th tone level, because they are octaves and therefore equivalent. The legend says, as Pythagoras was thinking about how he could make sounds measurable, he passed a blacksmith house. He heard the intervals of the octave, the fifth and the fourth as the craftsman hammered. As he examined the hammers, he measured their weight 6, 8, 9, and 12 pounds. He was now able to make this measurable on a straight stick, monochord, with these same weights that he hung on strings. Here again is the so-called basic or full cadence as a graphic. It is the tones 1, 4, 5 and 8, as well as their frequency relation 6:8 to 9:12. The tradition covers 2,500 years of our history. I show some photo evidence here, arranged chronologically. oldest written version of the legend about the Pythagorean Tetraktys is presented by the Neo-Pythagorean Nicomachus of Gerasa, who lived in the 1st or 2nd century AD. This is followed by Boetius at the turn of the 5th and 6th centuries. Musica Enchiriadis from the 9th century, Francinus Gaffurius, a Renaissance composer and music theorist. The most impressive evidence of the transmission of the numerical canon of the basic cadence is the fresco by Raphael in the Vatican, which the Renaissance painter discovered in 1611. On the black tablet that can be seen in front of Pythagoras, the proportions 6, 8, 9, 12 are in Roman numerals, below are the Greek names of the intervals, below are the Tetraktys and their sum 10. The blacksmith legend is certainly physically incorrect in one respect. We can see this in Francino Gaffurio's depiction of 1492, which corresponds to the written tradition. If you hang weights on gut strings, the weight force must increase quadratically so that the pitch increases linearly. So instead of 6, 8, 9, and 12 weight units, 6 times 6, 8 times 8, 9 times 9, and 12 times 12 weight units would have to be hung on strings so that you can hear the pitch relationships 6, 8, 9, and 12 when you strike the strings. This mathematical relationship applies to a variety of physical phenomena such as the gravitational force, the electric field force, but also to solid body vibrations, such as sound tubes, bells, bowls, and plates. The electric field force is distributed spherically around a central charge. If the areas grow in units of 1, 2, 3, 4, and so on, the distances must grow in square root sizes, i.e. square root of 1, 2, 3, 4, and so on. The field force then decreases inversely proportionally, as 1 to 1, 1 to 2, 1 to 3, 1 to 4, and analogously, sound tubes sound in exactly these frequency ratios when they are shortened to corresponding lengths. The cross-section and material of the sound tubes must be identical, and the relationship only applies to the first vibration mode, i.e. the fundamental vibration. I will quote again an early source of the blacksmith legend. Boetius, a Roman philosopher at the turn of the 5th to 6th century. He writes in De Institution Musica how Pythagoras measured the various proportions of harmony. By first hanging weights of equal size on strings and judging their harmony by ear, then making pipes of double and half size and maintaining the other proportions, he achieved absolute reliability through various experiences. If Pythagoras actually did that, then he must have discovered the physically correct relationships. However, nothing of this has been recorded. This relationship between simple geometries and solid-state vibrations applies to tubes, bowls, plates and bells for the first mode, the fundamental vibration. I have now outlined all the connections in order to understand what I presented at the Nuremberg Symposium in 2012. Here we see the elementary cell of sodium chloride, table salt. Many other salts crystallize in this simple cubic structure. The distances between the lattice ions are root numbers. The force effects in a saline elementary cell are determined by Coulomb's law. We are only interested in the relations, whereby all physical constancies are omitted. The law now becomes very simple. The force effects are relations of simple integers. If we were to hear them, we would hear musical intervals. You could also say, the crystal sounds. Although the distances are root quantities, the relations of the force effects are integers like the musical intervals. We find the classical intervals of the Tetraktys, the fourfold of the Pythagoreans. The minor triad proportions. And finally the basic cadence, that is, the frequency proportions, 6 to 8 to 9 to 12. The basic cadence with its frequency ratios is nothing other than a basic symmetry of space. The same applies to the other form of the Tetraktys and to the triad. Music is therefore not just a form of unconscious calculation with the proportions of simple whole numbers, but the expression of simple spatial symmetries. The volume proportions of the basic body of the cubic crystal system, in which 80% of all crystals crystallize, are also 6 to 8 to 9 to 12.